The values of a 2-pi periodic function ft over one full period is given by ft equal to 0 when t between minus pi and 0 equal to t if t between 0 and pi. Let big F be the Fourier series of small f. Find f big F at 0 plus big F at pi. We use the convergence theorems here. So function f is given by this formula. So this is piecewise continuous period 2 pi. We don't need to grab it, but I grab it to see what f look like. 0 from minus pi to 0. So say minus pi here. So equal to 0 between 0 and negative pi. Equal to t between 0 and pi. And here's pi. And equal to t. So it looks like this. So this is a graph, the graph of f in one period from minus pi to pi. For the other interval, just copy this pattern. So this is a graph of f, of small f. Now we need to compute big F0 plus big F pi. We didn't need to compute the Fourier series. We just need to use the convergence theorems. So the Fourier series of f, so big ft equal to small ft, or I say t0. If small f is continuous at t0, and Fourier series big F at t0 equal to the average of the limit. So we say limit ft t tend to t0 minus plus limit ft t tend to t0 plus over 2 if f is discontinuous at t0. We in fact can use this same formula for all t0 because if the function is continuous at t0, the left hand limit equal to the right hand limit. So this one n equal to f at t0, so 2 times f at t0 over 2, which is f at t0. Now we look at the 2 points here, 0 and pi. 0, left hand limit equal to right hand limit equal to the actual values f at 0. So the function is continuous at 0. The function is discontinuous at pi. That's the remark we have. F is continuous at 0 and f is discontinuous at pi. So we know that the Fourier series big F at 0, big F at pi is small f at 0 because of the theorem big F at 0 equal to small f at 0 because f is continuous at 0 for f at pi, big F at pi is a limit. So in short, people can write f t0 minus plus f t0 plus. So that one stands for the limit. F t0 plus over 2. So I use that notation. F pi minus plus f pi plus over 2. So we compute the left hand limit and right hand limit at pi. So f limit of f of t tends to pi from the left equal to f of pi equal to pi, because the function is defined as ft equal to t for t between 0 and pi. So the left hand limit is pi, right hand limit equal to 0. So this one is f at 0 equal to 0. You look at the graph, you see that here, equal to 0 plus pi plus 0 over 2. So this one equal to pi over 2. So that is the answer for this question. So left hand limit f tends to pi minus equal to pi. Right hand limit f tends to pi plus equal to 0. And that is why we have this one equal to pi over 2.